Now, we just finished this. Two angles are coterminal with each other if they share a terminal ray, okay? And the coterminal coworkers, coworkers work at the same place, coterminal end at the same spot, okay? In general, any given angle theta, its coterminal angles are given by theta subcoterminal, that COT, that's really representing coterminal, is equal to theta plus 360, or you ready? Minus 360. Crazy, right? Because any positive or negative rotation back to that coterminal angle is another coterminal angle. We could be here all day, right? And because of that, oh, by the way, n is a subset of the z, the integers set, okay? So now, if we're looking at this, if theta is equal to 465 degrees, let's talk about what that might look like. Theta is equal to 465 degrees. That's 360, okay, so far. And I got to go another 105 degrees, right? Are you in agreement that I got one more 105 degrees is like right there, within reason, okay? Are we all right with what I've done? Now, yesterday, this black, we were talking about 465, okay? Now, what they're asking us to do is find all the angles that are theta coterminal, which means coterminal with the original angle theta, okay? And we have that subcoterminal. We're saying that, hey, these are also in the same spot, okay? So we can do multiples of 360. So I can add 360 to 465, okay? And I can take my calculator out, grab it, 465, pop it in your calculator, and add 360, and maybe add 360 again. And here's the range they give us. They want all of the coterminal angles between negative 1,000 degrees and 1,000 degrees. So we are going to do multiples of adding 360 and, because I said that earlier, subtracting 360. So find them all. Go. Find my list. Okay, 465 is on it, but all the things that are coterminal with 465. Theta coterminal. And I try to fix this video issue I had earlier. We're just going to copy this. Now, if you would, you were introduced to your row partners yesterday. If you could compare your answers with them today and greet them again, and after you do that, ask them how today is going. Okay, so did your answers and my answers maybe come out to be the same here? 825, 975. Did you get those? Now, I'm not sure if you're paying attention, but we're starting to have a lot of little nitpicky variables to work with. Although that 465 was theta, okay, all these are theta coterminal possibilities. Theta subcoterminal. So that's what that, when we do that coterminal, we're talking theta coterminal. And I continue, well, okay, I got one more, so let's just finish it out. So all those are theta coterminal, okay? What's theta reference to 465? Okay, do you remember reference angles? Okay, now we talked about it yesterday, and we probably went right towards the end, and everybody's like, oh, it's almost time to go. I'm so excited to leave Bloom. He's kind of a hemorrhoidal issue, so you know, I'm out of here. Okay, so what do you got? What? 105. How did you find 105? Because we're going to talk about it, because you are next to an x-axis, but it's not the closest x-axis. We're 15. So bring it down this, what, 75? Yeah, 75. So I see where you're going, okay? But here's the deal. A reference angle is the positive angle made by the terminal ray and the x-axis. And it's always less than 90. And people are like, what? So in this particular case, it's this angle. Okay, since this was, remember, I was kind of like, hey, I got 360. How much further do I got to go to get to 465? And you go, well, 105, you knucklehead. Okay, well, here's the deal. I've gone 90, and I go 15. This is 15 away from that axis. So I should have a theta reference angle that's 75 degrees. A reference angle is the positive angle value between the x-axis and the terminal ray, and we will use those a lot. Okay, that's called a reference angle. It's always with the x-axis, not with the y-axis. Okay, are there any questions about it? Theta reference, REF, maybe perhaps Bloom has to, you know, write better. It's theta reference. It's the reference angle to the theta degrees is going to be 75 degrees. Are there any questions of how I came up with 75? Yes, sir. Reference angles will always be positive values. Okay, although we're even getting there, you know, for a what if, let's bring that up here. Because what if I was down here and I got here and this is like 135 and it was negative 135. Okay, that was my my original theta. My theta reference would be 45 degrees. That direction, okay, when I'm talking about it. Does that help? And there are formulas for it, and I'm going to show you them. But really, what I want you to be thinking, how far have I gone, in what direction, and how much farther do I have to go to get to 180, okay? Because the difference, okay, is going to be my reference angle. If it's in any other quadrant other than quadrant 1, okay? The reference angle in the theta in quadrant 1 is probably going to be the same angle. If this is 30 degrees, my reference angle will be 30 degrees, okay? Let's assume that I started from the origin there, okay? Does that make sense? Any clarifications on those? Okay, so that was kind of a review of coterminal stuff, but also a touch on our reference angles, and we're going to be doing some more reference angle stuff here. But let's talk about rotations here. For each angle phi, excuse me, this is phi, find the angle theta coterminal with phi such that theta is between 0 and 360. Okay, you notice how I'm limiting where to find it? In the future, we may not have a limit, and I may have to talk about multiple revolutions to get back to that spot. But for right now, we're just going to have a limit of where we're looking. So if I have negative 28,549, okay, I know, it's really cool. All right, I want you to find phi. It's a coterminal angle with that. That's between 0 and 360. Okay, so the first thing is, get it down to a portion of a revolution. So take 28,549, divide by 360. Hammer, did you walk in with us? You walked in with us, so they handed it to me.
I did not walk.
Okay, good. I just wanted to make sure. I end up picking those things up off the floor, you know. I just got to grab myself a calculator. So we got 28,000. What did you guys get? How many revolutions? That's a big donut of revolutions, isn't it? 79 revolutions. What's the partial left? Okay, so take away 70. Well, okay, depending on how you did it. Get rid of the 79. Okay, and then multiply what you have left by 360. So now if I get rid of my 79, I've got to add my 79 in because I'm doing negative, times 360s, you got 109?
Yeah.
Okay, so I got 109 degrees. But keep in mind what this is looking like. I got a negative 109, right? So negative 109, that's negative 90. And what negative 109 is down here, and gosh, my board is just off. So let's see if we can fix that a little bit. Okay, so I've got a negative 109. How much further away from 180 is that? And people are like, well, geez, Bloom, it's 71. Are you okay with that? Yes or no? I got 71 more degrees. And although it started as a negative value because this is negative 109 because that was coterminal with my original. So this is theta coterminal because it terminates in the same spot. My original theta, or excuse me, theta phi. I'm using phi. I apologize. That was phi coterminal because it's the same spot. Phi 28 negative 28,549 should end in, right? I have a 71 degree reference angle, the positive angle between the x-axis and the terminal ray. Are you okay with this?
Wait,
Yes, sir.
so phi coterminal is negative 109.
Phi coterminal is negative 109. Yep. And phi reference, which is theta here, should be 71. Maybe. Okay. But are you okay with what we're doing? Well, it's 251. I got 251 when I did that. We went 360, 109. No, I'm happy with what we did. Yeah, I added 360. I'm not going to worry about it. Now, here's the thing about this. Did I do this right? Now I remember what I was doing. Is my answer in the range I was supposed to find it? No, you're rocking your head like we're going down a really rocky road and you got a bobblehead. That was awesome. I love that. It's like, no, Bloom, you're wrong. We're right. We're just not between 0 and 360. How would I get there? Add 360. So I'm going to add 360 to 109. What do I get? Do I get my 251? Phew, we're right. Okay. Excuse me, I just got to answer this. This is Mr. Bloom's. Eliana Jetman? Is Jetman here? Eliana? No. Not in this hour. At least I don't have her here now. Okay, thank you. Been on a revolving door of people wondering where other people are today. So, are we okay with the fact that I had, since that was negative 109 plus 360, that's where I get my 251. Okay, but now here's the thing. Is my reference angle still the same? And people are like, yeah, but you changed the value. But remember, that's 251 going this way. And what's 180 plus 71? Yeah. Are you okay with where I got 180? I've got some stairs. Straight angle, 180 degrees. I go 71 more because of my reference angle. It should be the same as my terminal ray degree. Are you okay with that? Yes or no? It scares me when it's quiet. Claire? Question? Yes? No. You're lying to me. That look, that stare was a question. I don't have a funny uniform on it, at least not today. Okay. We're doing okay? We're okay with coterminals and reference angles so far. Your turn. Again. Remember, it's between 0 and 360. Okay? Although you might find a negative one, positive one, 0 and 360 is where the phrase should be. Yeah. No, you can't have a notes. Here you go. Yeah, I prefer you guys pick these up rather than print them off at home. Thank you. And remember, your calculator is your friend on this when we're setting these up. You can tell the creativity from making up problems is kind of like taken care of if you just kind of like keep counting. Share with your friend what your coterminal answer was. Share with your friend what your coterminal answer was. Make sure you're doing this.
Sorry.
Because if you're not doing this, we're in trouble. Yes?
Yes, we have.
Okay. Yeah.
About a .9. Should we round up to 310?
No. Just take away the 309. Wait. Oh, yeah. 310. Yeah. Oh, I know what you're talking about now.
Oh, I already
God.
did that part.
Jim, yeah. I know. Sorry. I had to be on the same page, and I was like worried about her, and you're right. Yes! so let's run that back. So yeah, I like 310. Okay. Now we have a 310 degree coterminal angle. We okay with that? What's the reference angle at this for this? 50. Are you okay with that? And why we came up with it. Remember, reference angle is the positive angle, positive value angle between the x-axis and the terminal ray. Now, don't write these down. I got them here because they're rules, okay, to find reference angles. And we've been talking about the reference angle, and I'm a little bit ahead of myself, so I apologize. But a reference angle is a positive acute angle that measures the angle between the terminal ray and the closest x-axis. So it's always less than 90. Okay? Now, if it's in quadrant 2, 180 minus your theta will give you the reference angle. And some of you have already figured this out. So this is unimportant information. You don't need a formula for it if you already know your terminal angle, right? You all right with that? Here, your reference angle and your, in this case, theta, are the same because your angle's less than 90 and so is your reference angle, and they're both positive. Here, you've got to do, hey, I get my theta, I subtract 180, and it's what's left to get there. Okay, and that makes sense. Here in this in quadrant 4, if I take 360 and subtract my theta, okay, 360 minus my theta, where theta would be here, I get my theta reference. Or 360 minus my theta will give me my theta reference, which is the stuff left over, to the axis. Does that make sense? Okay, so this is the formula version of doing what we've been doing. Okay, it really truly is. You already know it. I'm pretty confident with it. And one of the reasons why I didn't put it in, we didn't put it in your notes, but I left it in these. I wanted, sometimes people go, well, is there something that I can like read to look at? And I go, yeah, it's this. Okay. Now, with that said, we have an example. Example 5.5. I want you to find the reference angle and the coterminal angle, the 565. I think it's 565. Go. Thank you, dear.
Yep.
Flint?
Yeah.
Yeah. Okay. Sorry, man. I was just trying to decipher that. Okay. So we got 565 coming around. How much bigger is 565 than 360? You okay? Or you looking at 205, right? So I got 205. That's 180 plus 25 more, right? Well, that 25 more is my reference angle. 25 degrees. Are you okay with my reference angle being 25 degrees? So my alpha reference is equal to 25 degrees. my alpha coterminal. Now, they were pretty open-ended on this question. I have a coterminal value that's positive right now, 205 degrees. Are you okay with that? Do I have a coterminal that's negative? What coterminal is negative? 155. Are you okay with that?
You have to write those both down.
Yeah, well, I'm going to talk about this for a second. Did I give you a limit to how many or what your range of coterminals were? This is a nasty, horrible, Bloom, I can't believe you did this to me problem. Because you have to consider the fact that we could go on and start listing coterminal angles and be here for the rest of our lives. Anybody got just bored out of their mind, got some free time? Right? You just want to start listing them and we'll just come up with it. So let's talk about what coterminal angles really are. Full revolutions later, right? A full revolution, whether positive or negative revolution, comes back to that angle. Are you okay with that? Yes or no? So what I'm saying is, think about what I just wrote. I just took care of every coterminal possibility coming back to those spots. Full revolutions of 360, positive or negative, because I said Z can be a member of the integer set. Or excuse me, N is a member of the integer set. That's what that notation means. So I've got alpha coterminal is 205, but so is anything that's a plus 360 going forward or backwards. Okay, I also have negative 155, but this covers it, so I don't have to say both. Does that make sense? I could have started with either one of them and covered all of them. But I just thought I'd talk about the positive one, the negative one, and then go, what about all these other possibilities? So they're all 360 combos. Is it making sense? Da? Net? No nets? I'd like to go fishing, so get a net. No, just kidding. All right. So that's 5.5. Let's look at 6. Okay? Let's talk about 6. And let's look at this one a little bit. Will I be able to save some time if I skip this one? Let's skip 6. I'm going to save some time. We're going to come back to this tomorrow. I want to start with 6 tomorrow. Okay, this is supposed to be the start of day 2. And before we get started, I want you to watch this. This is about radians. There's no music. A radian is based on the definition of the radius of a circle. And it's where it wraps around the circle. That is the length of 1 radian. Okay? Now, we're going to go to 2 radians. Does that make sense? And remember, radian is defined by the radius of the circle. That is 3 radians. What's the value of pi? 3.1415. No way! That is the circumference of the circle in terms of radians. And 2 pi is 6.28. And right now, that's the circumference of that circle versus 2 pi. If I can bring that down so you guys can see those values. This link is right now sitting in Schoology, so if you want to like review it and play around with it, you can look at it and have a little fun with it. It was provided to me by, I got to make sure it's in the video. It was provided to me by Mrs. LaRude, and I shared it with the other instructors. But I thought it was a pretty darn neat way to see the visual of the radian. Okay, that's why there's 6.28 radians in a circle. Okay, does that make sense? It's weird, right? It's all about the circle going all the way around. We're going to do one more time. And you can speed it up, but I want you to make sure you see it. And who says you can't show a movie in math? Now, are you okay that that's 3 radians, and then the partial is 0.145? Boy, that's crazy. 3.14159 is pi and 0.14159. Okay? And then, so this other part is pi. So actually a circle has 2 pi revolutions. Okay? That's 2 times around radian-wise. Okay? But remember, that's the same as 6.28 radians when I talk about 2 pi revolutions. Okay? Now this radius is 7, and we're talking about s divided by the radius, and we're talking about how many radians are in this circle. We could also talk about s being the length, and you're going to find that out, is the length. We're talking about the circumference in radians is s is equal to radius times theta. Okay? The length of your radius times your angle around, and theta would be in radians. It's pretty cool, right? And I think after this, bless you again, we start over again. This goes on forever. If you're ever looking for a stop, just hop off, okay? But it is a link that's sitting in Schoology right now, okay? So now, with that stuff in mind, in this book, we use degrees to measure angles in their geometric context, especially when applying trigonometry to real-world problems involving surveying, construction, and navigation, where degrees are still the accepted units of measure. When we work with trig functions, please notice this. When we work with trig functions, we'll measure angles in radians, okay? So that the domain and range values can be measured on comparable scales. Now, a central angle of a circle has a measure of 1 radian if it intercepts an arc with the same length as the radius. Now, that's what that video that we just did that from GeoAlgebra did, okay? GeoAlgebra. I'm having a hard time talking today. Boy, I'm lucky I've made it this far, okay? But that's what we're trying to get at. I could have explained it, but I thought that video did a much better job. Based on what we just learned from that video, I would like you to work with the people that you've been introduced with as row partners and answer those 4 questions, okay? I think I hit on all of them. I just want you to make sure that you know them, okay? So go ahead, read through, think about what we just saw, and hypothesize and answer the questions. And I'll turn it off at home so you guys don't have to wait through it. Okay, circumference is 2 pi r, okay? But in the video, you notice that s was equal to r theta, okay? Theta being the measure of the angle in radians, okay, measure of the angle in radians, we can represent it. What's the circumference of the circle in terms of its radius, r? So this is 2 of them, 2 ways I can look at the circumference in terms of the radius, because s, okay, s being the radius, so I could look at it, the radius times 2 pi, and 2 pi times radius. Oh, no way, it's the same thing. Crazy, right? Okay, so now, how many radians must there be to a complete circle? What did we find out? 6.28, right? Or 2 pi radians. If we cut a piece of thread 3 times as big as the radius, okay, 3 times as big as the radius, would it extend halfway around the circle? No, it would be short. How much would it be short? 0.14159, okay? And we'd be 1 point short to halfway. How many radians are in a straight angle? And people are like, what? Straight angle's 180. We're talking radian. What's pi? Okay, 3.14159 radians in a straight angle. Okay, I'll cheat and just put my angle sign in there. Is it making sense? Okay, radians shouldn't be, oh Jesus, just a miracle happens and Bloom comes up with R, and he's not even a pirate. but he might have a wood leg. We're not sure about that. He does limp. Okay, so let's move on. When we're talking about degrees to radians or radians to degrees, we have a conversion factor. We just learned that pi divided by 180 is our conversion factor because pi and 180 are synonymous. Or 180 divided by pi. Which one's which? It depends on our units that we're switching from. So keep in mind, radians is a unitless measure, and so is kind of degrees when we're working with it. So the conversion factor, as we're talking about, we got 1 degree. And I want to know what is 1 degree in radians. Well, if I got 1 degree, I'm going to multiply that by pi over 180. Okay, with 180 being degrees, degrees will cancel. Okay, and I've got pi. So I multiply, and I get my radian. That's my radian measure stuff, and this is for radians. So I've got 1 degree is 0.0175 radians. Okay, 1 degree. And it makes sense because there's 3.1459 radians in 180, so yeah, it kind of makes sense that 1 degree is really small in radians. Okay, are you okay with that? Switching it around, conversion factor, what is 1 radian in degrees? Okay, so remember, 3.14159 radians in 180 degrees. So we flip that around. It should be something less than 60. It is. Okay. And how did I know that? It's something less than 60 because 3.1459 is bigger than 3, and 180 divided by 3 is 60, so it should be smaller. Okay, number sense wise. Are we doing okay with this, conversion wise? You're going to be expected to be able to convert from radians to degrees and degrees to radians. Okay. Now, with practice, we can perform these conversions in our head to be no problem. And some things go pretty well. They're pretty fast. Like I know 180 is pi. Okay, and it's 3.14159. Okay, but if half of that, well, what's half of pi? Well, that's pi over 2, right? So how many degrees are 90 degrees? So get your solve on and get her done. Okay, so I'm going from degrees to radians. So I've got to put the 180 on the bottom. That's telling me about the conversion factor. It's all about physical science. And that's why I get my pi over 2. Okay, and now I'm going to let you in on a secret. We just learned that 90 degrees is the same as pi over 2. Okay, we are going to be using that when we work with our unit circle. So I'm going to leave it that way because it's a friendly number. Okay, other than 3.14159 divided by 2, which is like 1.55 whatever. Okay, it's crazy, right? So knowing that, how many degrees are in pi over 3 radians? So I've got that. Okay, you okay with pi over 3 is coming out to be 60? We doing okay with conversions? All right, great. Now, find the length of an arc intercepted by a central angle of half radian in a circle of radius 5. Half radian in a circle of radius 5. Now, I'm going to let you know a secret on this. Where S is the arc length, okay, remember arc length is, if this were pizza, arc length is the crust, okay? Theta is the opening, our central angle value, and R, of course, is our radius, okay? Now, if I'm asking you to find the central angle of a half radian, I'm asking you to find half of the radius. If I pop everything in, right? What's half of the radius? 2.5. Length of the intercepted arc is 2.5 inches because the radius is 5 inches. Okay, does that make sense? Now, please notice I use the formula that allows me to have theta as radians. Okay, in order for me to not use radians, I have to have a conversion formula. Okay, And that conversion to go from radians to degrees, what do you think? We did them already, okay? Now, find the radian measure of a central angle that intercepts an arc of length s in a circle of radius r. I just want you to solve that for theta. Find the radian measure, theta, of an angle, okay, that intercepts an arc of length s. I have an arc of length s in a circle of radius r. So I'm just asking you to solve this relationship for theta, and that's going to be s divided by r. S being the circumference, or the arc length, I should say, not circumference, but the arc length, the percent of the circumference of the circle. Okay. Now we did it in geometry. Okay, we did this arc length stuff, and it was like chapter 12 or 11. Yeah, 11. Okay, as you go through these. So make sure we're, kind of making connections. But you notice this is pretty quick and easy because it's in radians. Now, let's talk about what happens. Since central angle of one radian always intercepts an arc of one radius in length, it follows that a central angle of a radius in a circle of radius r intercepts an arc of length r. They're just talking, they're really working with the idea that a radius is a radian is one radius length. And this is the formula I was just talking about here. This should have been up here, by the way, and I apologize that it was not, but it will be in the future. Okay. Now, that is if theta is a central angle in a circle of radius r and theta is the measure of in radians, then the length s is the intercepted arc. Okay. But now, what if I'm not working in radians? Does a radians have units? Okay. The formula is S is equal to R theta implies an interesting fact about radians. As long as S and R are measured in the same units, the radian is a unit neutral thing. Okay. For example, if R is equal to 5 inches and theta is 2 radians, then S is 10 inches. I don't worry about the fact that I use radians. This unusual situation arises from the fact that the definition of radians is tied to the length of a radius. Okay, so that's just where it's at. If I'm going to do degree, please notice I underline degree measure, and I want to make sure you recognize something. This was originally, if I had this in radians, and I wanted to go and get it to degrees, okay? If I had it in, I should say, if I have it in degrees, I want it in radians. If this is my degrees, if I wanted to go to radians, I'd have to divide by 180 and multiply by pi. Are you in agreement with that conversion factor? Yes or no? Look at what they did here. They're saying, hey, theta's in degrees now. And this is what you have to do to the formula to make it work. If it were to make it go from degrees to radians, so I can now put in degrees and it automatically does the conversion for me. Okay, does that make sense? So it's a formula this to help me. If I know it's in degree, my theta, I can just pop it in and it'll switch it over. I don't have to think about putting in radians when I talk about this formula. So with that said, perimeter of a slice of pizza. Find the perimeter of a 60 degree slice of pizza with a radius of 7 inches. Go! I gave you the formula. Pop it in. See you, kiddo. Have a good day. Okay, remember, R7, theta is 60, because I'm using the formula when I have degrees to make it all work. Does that make sense? So I'm just popping stuff in. Okay? Are you okay with this? And it's evaluation time. 7 pi over 30, or 3, excuse me. And I can multiply that out and come up with this if I want. But my perimeter should be 7 plus 7 plus 7.330 inches, which is 21.330 inches. Okay, They ask for the perimeter of a slice of pizza. A lot of people get that little chunk of the crust, and they forget to add in the 2 radiuses that sandwich it. Does that make sense? Yes or no? .net. I got stares right now. We're doing okay? Remember, find the perimeter of a 60-degree slice. So perimeter is distance around 7 plus 7 plus whatever that is, and that's where it's coming from. Okay, last thing. I've got two equations I'm working with on this. I got equation of lane 1, an equation of lane 2. This is why we have a staggered start. But if you're going to race against somebody who doesn't know that, have them race in the outside lane so they are away from you because they run crazy, and you can run on the inside lane and do 2 laps. Okay, it'll be fun for you. Okay, but go ahead and find the difference on one curve, please. How you doing, kid? Good. Is it going okay? Making sense? Okay, so where have I missed you? Okay, because they're asking me to talk about the circumference. Okay, so I've got that on the inside curve, and then I got this on the outside curve. Okay, I'm doing the inside part of it, and their difference is 1 meter. Okay, so that's how I know that in lane 1, I've got 33 meters. So I'm going to put in my 33 meters, my radius for 33. How many degrees is this? Bing. Okay, does that make sense? And so I've got my 180 going through. So in this first one, I should be talking about that. Okay, does that help? Okay, good. I think it was the 180 that probably threw people. Now, I got 33 pi in the first one. Are you okay with that? And then the next one, you know, it's very similar. The radius is 1 more meter because the lanes are 1 meter wide. Okay, so I got 34 meters. But remember, the difference here is just the length of the radius. I'm still looking at the arc being theta, which is 180, or pi, and now it's 34 pi. Okay, so I'm aware right now their difference in running is 3.145 meters for one curve. Okay, does that make sense? And that is the conclusion of today's notes. Okay, I know I need to clean up that other problem, but I knew that I would be overtime on other things, so you can cover all the things you need to on today's assignment, and we will go over that other problem tomorrow as a starter. Okay, thank you so very much for your time today, guys, and thanks for the questions. I really appreciate it, and the feedback, because sometimes you're just staring at me. I'm like, oh my gosh, it's crickets. I'm never going to be a comedian. Okay, all right.